Okay, good morning everyone. Welcome to SEG209 and well done for making it to Mandalay Bay for 9 AM and finding this room. I also struggled. Did anyone do the 5K this morning as well? Nobody? Okay, cool. I believe it's fair to say that we are now living in a world where a single developer can build and deploy enterprise-grade applications that once required entire operations teams. As serverless has changed the game. We can now build software as a service or SaaS applications that scale from 0 to millions of users, where we don't pay for idle and there are no servers to manage. Now, serverless is not new. In fact, AWS Lambda, which pioneered serverless, is 10 years old this year. And it now processes tens of trillions of requests every single month. Serverless is a modern standard for SaaS architectures. Now, my name is Thomas Moore. I'm a senior solution architect from the UK, and I work with software vendors as well as being a serverless specialist. Now, when I talk to my customers, on a daily basis, they tell me they want three things. They want to modernize, they want to optimize their costs, and they want more time to focus on what matters to them. And hopefully I'm going to show you how in this session with serverless SaaS. Now, I want you to keep in mind that SaaS is not just a business transformation. It's a technical and a business transformation, and it's critical that both align in order to be successful. However, this is a technical talk, so we're going to focus on the technical side, and we're going to focus on three main things. One, we're going to understand the drivers for serverless and SaaS, like why serverless, why SaaS. We're also going to focus a little bit more on the technical details of how we implement multi-tenancy with serverless. And we're going to solve some architecture challenges using serverless patterns. And we're going to frame everything around a real-world example. So let's introduce that now. So hands up who has or currently owns a vehicle, a car, a motorbike, a van. Cool, and keep your hand up if you've ever had a bad experience in getting it serviced or repaired. Yeah, me too. So I often find that I end up ringing around loads of different places trying to get an appointment. I play calendar ping pong over the phone. And then when it goes for repair, they don't call me back and give me any status updates, and then I find there's a big bill at the end. So this is any company's mechanic management software that's designed to help mechanic businesses give their end customers a better experience. It's brilliant. For the end customers, it provides them with online bookings, service reminders, and the ability to do invoicing and payments electronically. For the mechanics themselves, it helps them manage parts and inventory, doing technician rostering, and also diagnostics inside the software itself. So this is just an example for today, and I want you to think as we go through the session about how everything applies to your own businesses. So let's see where any company have come from. And if you're an ISV, an independent software vendor in the audience, this might be a familiar story to you. So software originally launched as a download back in the early 2000s. Right? The mechanics would go online, pay a perpetual license fee, and they would download, install, and run the software themselves. Right? And these are mechanic businesses. They're good at repairing cars, but maybe not so good at running IT infrastructure. So for any company, this was a support headache, a support nightmare, right? Things would be installed different ways, badly, running on all sorts of weird and wonderful hardware. So to solve this problem and fast forward to the invention of the cloud, any company decided that they would host the software on behalf of their own customers. At this point, we can refer to any company as a managed service provider, an MSP. So note that they're not really operating as a SaaS company, and we'll go into reasons as to why later. Because of some challenges, again we'll go into these, the desire for next year into the future is to launch a serverless product and a SaaS product. Now, any company's customers come in all shapes and sizes, anywhere from a small independent family-owned business with a handful of employees, all the way through to a large national or international business. And from now on, I'm going to refer to these customers as tenants. And a tenant is a fundamental construct of building any SaaS solution. Right, a tenant is a user of the SaaS software. I want you to think about who the tenants are in your business. Now, this can become quite complicated to define, particularly if we think about those larger international businesses. Right, they may have grown organically over time through multiple acquisitions. And so is our tenant the outer company? Is it one of the subsidiaries, or is it as small as a single location? Right, it doesn't really matter how you define your tenant, but it's important that you do as early as possible, because it's fundamental to how you implement data, authentication, and permissions. So this is the hosted solution as it stands today. Each tenant has a copy of the software, and they all have a set of their own resources. At the moment, it's running on Amazon EC2. The application exists on some EC2 instances, and the database exists on some EC2 instances. Any company are responsible for making sure the software is secure, performant, and resilient. Tenant 1 is running version 1.2 of the software, a classic. Tenant 2 is running 3.23, a much newer version. And Tenant 3 is running 1.46, but a slightly customized version, because they're one of our larger customers that demanded that they had a custom plugin to integrate with their marketing system. Now, this is one of the symptoms, or one of the signs, of an MSP versus a SaaS provider. We've given control over to the tenants as to which version they run, and we've offered these customizations. When we build SaaS solutions, we look for a unified experience with seamless onboarding, and it generally leads to all tenants running the same version. So what other current challenges are there? Well, tenant 1 is complaining about when a new feature is coming out, right? The feature's already out, but they're running an old version, and maybe they don't know how to upgrade, or it's too difficult for them to upgrade. Tenant 2 has the latest version, but the competitors of any company offer better capabilities at a lower cost. And Tenant 3 is complaining about the length of time it takes to onboard, to get up and running and actually using the software. Any company are also complaining. Low usage tenants are costing money. Right? If some tenants are not really using the software very much, we still have to maintain a minimum number of EC2 instances across multiple availability zones to make sure it's available 24/7 and it is resilient. Tenants can't use the latest features until they upgrade. Rolling out security fixes is hard. Right? If we have tens or hundreds or thousands of tenants, even with good automation, we've got to roll out operating system updates, runtime updates, application updates. It takes a long time. And getting insights from the data is hard. Right? Because we've got a database instance per tenant, we've got siloed data, so how do we do analytics? So we can summarize all these challenges into 3 visions for the future. 1 is a faster time to market, 1 is to reduce the costs, and 3 is to increase innovation. And to do this, any company are going to strive for all tenants on the same version of the software, look to move towards multi-tenant solutions with shared resources, shift more responsibility to AWS, and reduce those data silos. So what we're talking about is serverless SaaS. So why serverless? Right? Managing servers is hard. I used to manage servers for 10 years plus, and I've spent a long, long time configuring operating systems, hardening operating systems, deploying automation to do all the deployment, to do the security fix rollouts, and it was an awful lot of energy for very little value to the end customer. Right? Serverless removes the servers and allows us to get straight to writing the value, the functionality that our customers are asking for. It also automatically scales for us as requests come in, and it scales back down to 0 when they go away. It's also highly available out of the box, which means it's architected across 3 availability zones, and we don't have to think about that. Why SaaS? Because it's what customers expect in the modern world. Right? They want the latest features and they want them fast. They don't have to worry about how they upgrade. And for us as any company, we want seamless onboarding, we want operational efficiency, and we want to be able to adapt to changes in the market. So remember that SaaS is not about building a product, it's about building a service. Right? Think about how customers are onboarded, how quickly they achieve value, and how you introduce new features to address their needs. So again, think about getting a car repaired, right? You care about the quality of the repair, of course, but you also care about the service, how quickly you can get it repaired, how easy was it to book an appointment, what was the communication like. And to deliver this service in a SaaS solution, when we talk about SaaS at AWS, we talk about the importance of building a control plane, a set of services that sits outside the application that control metrics, onboarding, administration, billing, and more. Right? This is how we can achieve the service that we expect. Now we're going to focus on the application plane today, and we're going to dive a bit deeper into building a multi-tenanted application plane using serverless. So we'll start with an introduction to serverless, we'll level set what it is, and then we'll build up our architecture as we look at the entry point, how we manage permissions, data, how we communicate between services with integration patterns, and then we'll look at updates and migration. So let's start with an introduction to serverless. What services are available to us in AWS to build a serverless application? Amazon CloudFront is a static content distribution. This is a content delivery network that uses a 450 plus edge locations around the world to get static content closer to the end users. All right, it can also allow network access into the AWS backbone much faster than going back to the region. And for a multi-tenanted solution, we can also do things like dynamic origin routing. We can control security policies at the edge and more. For APIs, we've got Amazon API Gateway for building RESTful APIs and for provisioning WebSockets. And for provisioning GraphQL APIs, we have AWS AppSync. For authentication, we have Amazon Cognito. Amazon Cognito has got a whole bunch of new features and capabilities in the last few months. This is where we manage our identities, our users, and permissions. AWS Lambda, I mentioned right at the start. This is a fundamental service. This is where we write our business logic, our custom code. And we can write that code in one of the managed runtimes, be it in Python, .NET, Java, or Node.js. For storage, we have Amazon DynamoDB as an ultra-low latency key value store, and Amazon S3 as a highly durable object store. And then in the middle, we've got a whole bunch of integration services. This is the glue between our microservices. This is how we communicate between them. So step functions can do orchestration. We can build workflows to create a set of sequence steps. Amazon Event Bridge can do event routing and help us build event-driven architectures. Amazon SNS can do publish-subscribe models, so we can send into a topic and then fan out to multiple subscribers. And then SQS can provide us with message queue capabilities. We can send to a queue and receive messages from a queue. So just to recap then, all of these services are serverless. They scale automatically. We don't pay for idle, and they are highly available across multiple availability zones. So if you think about when mechanics shut down for the holiday season and there's low usage in the system, right, this will scale right back down and reduce our costs automatically. When one mechanic comes online and starts to run reports for parts and inventories and bookings they've had over the last 5-10 years, right, these will automatically scale up again, and we won't impact our other tenants. And for any company with their small DevOps team, there's no servers to maintain, manage, or patch. So if we put these building blocks together, we can build virtually any application that we like. But a common starting point is the serverless web application. Right, we're going to need a web UI to give a portal for mechanics to log in, to be able to manage the jobs. We're going to need a portal for reception staff to log in and manage the bookings. And we're going to need somewhere for the end users to make those bookings. So here's what that architecture looks like. Users come into our entry point, our CloudFront distribution. And behind that, we've got our static content in an S3 bucket. This is our HTML, our CSS, our JavaScript. Essentially, this is the static code from a modern web framework such as React. The JavaScript will be downloaded to the browser, and the browser will call back for dynamic content. And this dynamic content will go through API Gateway as our front door. Behind there, we have a series of Lambda functions, and then we read and write data from DynamoDB. This is a common pattern that we see. It's simple and it's easy to build. If we were to take this model and deploy it in the same way as any company do today with the hosted solution, we'll look something like this, right? Each tenant would get a copy of the resources. And this already has benefits over the existing architecture. In that it's serverless, it scales, we shift responsibility to AWS. But the challenges come on the management side, right? If we scale this up to tens or hundreds of users, tenants, it looks something like this, right? We've got now decentralized monitoring and management. If we have to roll out updates, we have to do it many, many times, even with good automation. If we have to monitor this, there's loads of different components to monitor and keep an eye on. And we may end up with duplicate data as well. So this is really not going to improve our operational efficiency. So what we're going to look at to solve this is the pooled model, where all tenants share the same set of resources. This has the benefit of being more efficient, faster to deploy, and a simplified operation. However, there are trade-offs, as with any architecture and I suppose anything in life. Right? The challenges come with how we manage tenant isolation. How do we stop one tenant from accessing another tenant's data? What about noisy neighbors? How do we stop one tenant from impacting another tenant's experience? And scope of impact. What happens if we do a failed update and we take down all the tenants? So we're going to look at how we solve these as we go through. So let's look at the entry point to start with. Now when our tenants come into the system, right, they're either going to come in through our web UI, which we mentioned, or they'll come in through direct API integrations if they're maybe one of our larger tenants. In either case, it's going to be standard HTTPS, and for that, we're going to need a domain name. We have some options for our domain name. One, we could create a generic name that all tenants share, so portal.anycompany.com. We could also put the tenant context inside the URL, inside the path, or we could give each tenant their own subdomain, right? With these two, we have the tenant context as soon as they come into the entry point. We could also give each tenant their own custom domain, right? They might want to do some custom branding, for example. So how would we implement each of these? Well, the first two would implement in the same way. We'd create an alias in DNS inside Amazon Route 53 that points to the CloudFront distribution. Then we can use AWS Certificate Manager, or ACM, to issue a free public certificate and associate that to the CloudFront distribution. If we were to implement the second option, it gets slightly more complicated. In that now, every time we onboard a tenant, we have to create a new DNS entry for them. When we offboard them, we have to remove it. Our ACM certificate is now going to shift to a wildcard to help us scale the solution. And the last one is the most complicated to implement, because now either the tenants have to point their DNS at our CloudFront distribution themselves, or we have to manage the DNS on behalf of those tenants. When it comes to the certificate, we're going to end up having to create multiple subject alternate names, or SANs, in ACM, which has a certain limit of scale, and then you have to create multiple CloudFront distributions. So this is a valid option, it's just a little bit harder to implement and maintain. So we're going to look at the first option without any tenant context in the domain, and we're going to find out how we get that tenant context through the login. So when users log into the system, we'll prompt them for a username. And we can use this username to look up which tenant they belong to. Note at this point, we're not prompting for the password. If we find they belong to one of our smaller tenants, we'll take the default path and we'll prompt them for the password, and we'll authenticate them against our identity provider that's built into the system, maybe Amazon Cognito. This will use a standard OpenID Connect protocol. Now what will be returned is something called a JSON Web Token, a JWT or a JOT. What a JWT is a signed token that allows you to go and access other services. It's signed as in it's signed with keys from the identity provider to validate its integrity. And inside it contains information such as an expiry date and some claims about the identity, so their name, which tenant they belong to, what role they have. Now going back to that username lookup, if we find that this user belongs to one of our larger tenants that wants to bring their own identity provider, we can redirect them to that that tenant's own identity provider's login page, which might have PIN and MFA, for example. And as long as it uses OpenID Connect, will still be returned a JWT. So now we have our entry point, our login, and we've got a valid JWT. Let's look at how we use that to authenticate against our serverless API. So the web application will now pass that JWT token back to API Gateway. And it will do this as a HTTP header, an authorization header or bearer token. Now we need to add another piece to our architecture. This is called the Lambda Authorizer. And what the Lambda Authorizer does is it's a small piece of code, it's a small piece of custom code that you can use one of the custom runtimes, so Python, Node.js, Java, .NET. And the job of the authorizer is to essentially decide on whether the request is allowed or denied. And whatever logic you do inside there is up to you. But we need to verify our JWT, which involves speaking to the identity provider, getting custom keys, validating its integrity, making sure it's not expired, and then checking maybe the user's role to see whether they're allowed to authenticate against this or authorized against this particular API call. What we can also do from the Lambda Authorizer is return what's called a context object. And a context object is essentially some key value pairs of anything you like. So it could be the tenant ID, right? This is really critical for our SaaS application. So we can either extract the tenant ID directly from the JWT, or we could look up against a DynamoDB table or something like this to resolve it. The Lambda Authorizer will pass that tenant ID and the rest of the context object back to API Gateway, and then we can configure API Gateway to send it to the downstream services. So we can send it as a HTTP header, as a query string, a part of the path, or if we're using Lambda, it will go as part of the event payload input. So hopefully everyone's still with me. So we've got our domain, we've logged in and authenticated, we've returned a JWT, we've authorized through the API using that token, and we've returned the tenant ID to our downstream microservice. So let's look at how we use this context of the tenant to store and access data. Now remember I said in our architecture we're using two services, we're using DynamoDB and S3. We need to ensure the tenant context is present when we write data as we're using the pooled model. So for DynamoDB we can use the tenant ID as part of the partition key or the primary key. Right, remember this is a table that's shared by all of our tenants. Now in reality, to avoid hot partitions, we would add some randomness to the end of the tenant ID, but this is just there for simplicity. For S3, we're going to use a prefix per tenant. Now, you could use a bucket per tenant, and S3 has recently increased the default quota from 100 to 10,000 buckets in an account. You can request up to 1 million. But it's still a little bit more overhead for us to create those buckets and delete the buckets as tenants onboard and offboard. So for scalability, we're going to use a prefix per tenant. This is how the data is stored, but how do we access it securely? Well, it's our Lambda functions that are accessing the data. With a Lambda function, we have this thing called an execution role. And what the execution role does is gives the Lambda function permissions to access other services. In this case, we've given it a DynamoDB get item access to the jobs table. So we've given it read access to DynamoDB's table. Now, inside the code, you would create a filter expression or a where clause when accessing this data to restrict it down to the tenant that you're interested in. But if there's a bug in the code or something goes wrong, then you might accidentally access another tenant's data. And this would be catastrophic to any company's reputation. So how do we solve this? Well, we can use the tenant ID that's passed into us from the API gateway. What we can do with that tenant ID is dynamically assume a role at runtime. So we dynamically create this IAM policy inside the Lambda code, and then we assume another role outside the execution role in order to access data. So you can see that we're using a capability called leading keys inside IAM, and this will restrict the access down to only that tenant ID inside our table. So now, even if we tried to access tenant 2's data, we would get access denied. Now, this is one way of doing it. There are other ways. You can use things called session tags, and you can use things like assume role with identity. Assume role with web identity. And there are loads of blogs on this if you want to go and check that out. We can do the same thing with S3. When we access the data, we can put the tenant ID inside the resource and scope permissions down to only that tenant's files. So now we can't access tenant 2's invoices. So far we've looked at storing and accessing transactional data. Let's have a brief look at how we do some analytics. Now remember that we said any company had this problem of data silos, and they want to try and break these down in order to help them understand how people are using the software. It will help them do pricing, help them build new features. For example, we might want a feature that helps a customer decide on the best brand of parts to use based on failure rates. So these are some of the analytical type questions that we might want to ask, which is really hard in our current architecture because we'll have to have loads and loads of ETL jobs into a central analytical store in order to get those answers. But now we've got pooled databases, right? We've got shared DynamoDB tables and files inside buckets. Well, DynamoDB is great as a transactional store, but as we start to do analytical queries with complex joins, right, it's not really an appropriate place to have that. A better place would be to host the data in a data lake inside an S3 bucket. So how do we get the data there? Well, we can stream the data from DynamoDB using a built-in capability directly to Kinesis data streams. This is a change data capture stream. So when our create, read, update, and delete operations come into the table, they will get streamed straight to Kinesis in near real time. We can connect Kinesis to Amazon Data Firehose, which can do transformations with Lambda, and then dynamically partition the data into S3. So essentially we're going from this inside DynamoDB to something that looks like this inside S3. And note we've got our data still partitioned per tenant if we wanted to secure it that way, but we can also run queries across the data as well. And we can query directly to S3 using something like Amazon Athena. And with the latest announcements with S3 data tables, we can also get Amazon Data Firehose to stream directly into Apache Iceberg tables on S3. So let's shift gears a bit now, and so far we've looked at everything that's kind of a serverless API. But what about integration? What about when we want to communicate between our microservices that we build? How do we do this in the most efficient way? So far, everything we've looked at is synchronous, right? We send a request and we wait for a response. This is simple, it fails fast, and it's low latency. But what about if the receiver fails, right? We still want to take bookings for services and repair, right? We don't want to lose any business. What happens if the receiver takes a long time to process? What if we're taking payments and producing invoicing? Maybe this takes minutes or even hours to receive the data. What happens if the receiver suddenly gets loads of requests and is overwhelmed? Right? What if there's a heat wave announced next week and everyone goes to book in for their aircon regas? We can look at asynchronous architectures to help solve this, right? And we should try and use asynchronous where we can. So now we've introduced a queue in the middle. So when our sender sends a message, it goes straight into the queue and the data is persisted. So if the receiver fails, we still have that message in the queue. Our receiver can process those messages in its own time. If it fails, it can reprocess the message, and it can do them in batches to do things more efficiently. We can also use publish subscribe as well. This is also asynchronous, but this time we've got multiple parties interested in the same message. So we send a message to a topic, and that fans out to multiple subscribers. So let's see how we can use these patterns in our mechanic management software example. We'll start with asynchronous processing. So we've got a mechanic in the repair shop. They've just finished changing the oil, and they'll go into the software to mark the job as complete. This will send a request to API Gateway through to our Lambda functions and update the database inside DynamoDB. But now we also want to request payment from the customer, right? We want to create an invoice, generate a PDF, and then send them a request to make the payment. This is something that might take a little bit of time. So we can do this asynchronously by sending a message to Amazon SQS. We can create a Lambda function to subscribe to that SQS queue, and this is called an event source mapping, to generate the invoice and then store it in S3. This is just one way to process this example. There are multiple ways to send to the queue. Here's another example. A technician records a diagnostics video of the car, right, to help earn trust with the customers. Right, they want to show the repair that's required or show the repair that's been completed underneath the car. Once the video is recorded, it will go into an S3 bucket. And then we can use a feature of S3 called event notifications to automatically send a message to a queue when the file arrives. Again, we have a Lambda function subscribed to that queue. And what it's going to do is process the video, create a secure download link, and then use Amazon SES to send an email to the customer with their video link. Now, if we think about what's happening here in our pooled model where all tenants share the same set of resources, all the messages are going into the same queue. So tenant 1, tenant 2, and tenant 3 in the order that they arrive. One feature of SQS that we have to help us in maintaining that tenant context is something called message attributes. So we could use message attributes to add information, metadata about our messages, and here we can store the tenant ID. When you subscribe a Lambda function to an SQS queue and we set up this event source mapping, by default it has this batch size. So you can see there's a batch size of 10. And what this means is the Lambda function will receive 10 messages in one go and process them all inside one invocation. So why is this important? Well, if you think about our earlier example where we assumed a role to make sure we access data securely, if we've got multiple tenants' messages inside one invocation, we have to do that in a loop. Now we could set the batch size to 1 to avoid having to do this and only ever receive one tenant at a time. But this might not be the most efficient way to do it. Depends on the throughput to the queue. We could also give each tenant their own SQS queue. And this will help manage fairness and also avoid having to manage the permission issue. But again, it's more complicated to manage on the onboarding and offboarding experience, as we have to provision the queues and remove them, monitor them, and maintain them. So still on integration, we're now thinking about events. And often when we talk about serverless architectures, we talk about event-driven architectures, because that's the way the services are built. We pay for events. So thinking about when the mechanic has marked the job as marked a repair as complete, that's gone to our Lambda function, updated DynamoDB. But an event has happened, right? The job is completed. There might be other services that are interested in this, right? We want to send an invoice. We want to notify the customer. We want to create some internal documentation that the repair has happened. We want to update the parts inventory for anything that we've used. So we can send the event to a service called Amazon Event Bridge. And inside Event Bridge, we create what's called an event bus. An event bus, we can create a series of rules. And these rules essentially pattern match on the event and trigger various actions in parallel. So we could start processing the payment using a workflow and step functions. We could update the workshop capacity to say we're ready for another job inside a Lambda function. But what's really great about this is it's extensible, right? If we wanted to add a new feature in the future, again, to do that documentation update to help people in the future understand what the repair was if it was quite complicated, we can do this by just creating a new rule, and we don't have to modify any of the code, right? So this is very extensible and it's easy to add new features. This is what the event schema, the event payload might look like. There are certain required fields for Event Bridge, such as source, detail type, and the detail object. Inside the detail object, you can put any information you like. Remember to include the tenant ID to maintain that context. Now, we used step functions in the previous example, and remember we said step functions can be used for orchestration. So let's look at how this can help us. So again, our event of job being completed is going to Event Bridge. And we've got a rule set up to start the customer payment workflow, right? And here's our workflow. We're going to get some details from the database about the job itself. We're going to use Lambda to generate the invoice. We're going to send the customer an email to say the car's ready for collection. And then we're going to wait, right? And this is where step functions is really powerful. You can wait for up to a year. And because with standard workflows, you pay for transitions, right? While we're in that wait stage, we're not paying anything. Once the payment is complete, the workflow can continue. We can update the database, and we can send out a survey where everyone gives 5 out of 5. Now, we can use step functions as well to split up our orchestration into multiple sections and stitch them together. So this can become quite powerful. You'll also see that we're directly integrating with our services. So we can make direct SDK calls to pretty much all of the AWS services now to avoid having Lambda functions and some custom code to manage. Remember that our tenant ID is coming through from our event into Event Bridge and then into step functions as the input, so we can use this as we go through the workflow. Let's look at another example. Again, thinking about our technician car diagnostic video. Here's an example workflow. We could use Amazon Transcribe to get the video commentary from the audio and get it back into text. We could store that text in an S3 bucket, and then we could send it to Amazon Bedrock and use a large language model to summarize the commentary. We could then send to Lambda to retrieve the repair quote from our database, and then email the customer a link to the video, a summary of the video in text in case they don't want to watch the whole thing, and the quote for the repair. So now let's look at updates. Right, remember we said that we wanted to avoid impacting all our tenants when we do deployments. Now we're in this pooled model. So how do we get from version 1 to version 2 of the stack? Note that we've added in an SQS queue in this example. Well, hopefully we're using infrastructure as code, something like CloudFormation, Terraform, AWS SAM, CDK. We've got version control in place. We're using a Git repository as an example. And we've got some automation in how we do deployments. We've got CI/CD pipelines. Our application and our infrastructure code come closer together when we build serverless. And so we have this artifact which we're going to take through multiple stages, and we'll deploy our architecture into multiple accounts as we have this path to production. And hopefully our testing will help to remove any potential issues, but as probably we already all know, there's nothing really like production. So how do we solve this? Well, one way to mitigate the risk is to do a region by region deployment, right? If we're deploying this software around the world, chances are we're probably going to deploy it in multiple regions. And this might be for data residency reasons. It might be to just give lower latency to the end users. We could start with our smaller region, follow the sun model when software usage is lower, and this will mitigate some of the risks of rolling out to production. We could also use a cellular architecture where we have multiple copies of the infrastructure. So note this is not quite as complex as the siloed model where each tenant has a copy of the infrastructure. We have tens or hundreds of stacks. We may just have 2, 3, or 4. But again, it mitigates the risks because we can deploy to 50% of our tenants, and then when we're happy with that, do the remaining. Remember that it's important to have good automation and metrics to help you monitor and ensure it's successful before you move on. And finally, let's look at migrating the customers to SaaS. So we've got our old world of the managed hosting customers, and we've got the new world of serverless SaaS. So how do we get customers across to the new architecture? The last thing that we want is to manage both, right? This is only going to make things worse. So we could achieve complete feature parity, right? We could make the new world exactly like the old world and then migrate customers across. This is very, very difficult to achieve. We could offer incentives and discounts. Well, hopefully we've got some new features in the new world that customers are attracted to. Hopefully we've optimized our costs so that things are more optimal to us as any company, and we can pass those savings on to our customers. We can offer free trial periods. As we know, customers get hands-on with the solution, they're more likely to use it. Similarly, education and training is important, right? People know more about something, they're more likely to use it. Data migration assistance is really, really important, right? If it's difficult for the customer to go to the new world, then they're probably not going to do it, right? Give them a path where they can do a single click and all of their settings and data goes across. Don't make it difficult for them. And finally, we could do a legacy software deprecation where we set an end-of-life date and force the customers across. So let's summarize everything that we've covered. And I appreciate that there's quite a lot that we've gone through. So previously, any company had this challenge where tenants were not aligned, resources were not aligned to tenant consumption. Well, now we're using serverless. Things scale automatically as requests come into the system. Previously, it was slow to deliver new features. We've got a faster time to market with serverless. We haven't got to think about servers. We can get straight to writing our business logic, and we've got extensible architectures with things like EventBridge. New tenant onboarding was slow. Well, now we have no resource provisioning time. We don't have to size the tenants because they're all sharing the same set of resources. Time-consuming updates and maintenance, we've shifted responsibility to AWS because we're using serverless. And data silos, we've got shared databases with simplified pipelines. So what are the key takeaways that I want you to go away with today? Remember that serverless is a very good fit for SaaS because the tenant's consumption matches very closely to how serverless services are built and that they scale up and down for us. We don't really know how tenants are going to consume the software, right? They might do things that we don't expect. And serverless kind of takes that load as it scales up and down, and we only pay for what we use. Tenant context is fundamental to multi-tenancy. We need to maintain who the tenant is throughout the entire system, all the way from authentication to data, to how we do integrations and more. And those serverless integration patterns can help us create scalable solutions which reduce the time to market. So I want you to take what you've learned today, apply it to your own businesses and their own context, and hopefully go and build something to delight your customers. Now, if you wanted to get hands-on with any of this, there is a reference architecture available on GitHub, and it has a hands-on workshop which can walk you through building out some of these concepts. It also covers some more stuff which we haven't covered today around how you manage metrics and things like this. But otherwise, thank you very much for taking the time to come and hear me speak today. If you have any questions, then I'll be stood at the back for a while. I'll be happy to take those. And please, please, please remember to fill in the feedback survey at the end. I know everyone's saying this, but it is really, really important that you do so. Otherwise, thank you very much and have a great rest of the week.